So these are going to be Chapter 3 review notes. For this, I would suggest that you get a highlighter so that you can highlight a couple things or underline things that I talk about. The other thing that you might want to get out is a periodic table. I suggest you print one out from webelements.com. They have a nice, very simple one. So from your first year of chemistry, you should have gone over the parts of the atom. So we have protons are positive, neutrons are neutral, and electrons are negative. So please remember that protons and neutrons, these are found in the nucleus. And the electrons are then also part. And the electrons are really what we're going to focus on, and that's what we should focus on as chemists. Realize the protons and the neutrons are going to have most of the mass of the atom, and that is here. Note that the protons and the neutrons have mass, while electrons have very, very small mass. Realize that the electrons are in the empty space where the electrons are located. So a way to think about this is if we were at Soldier Field, if I had a P, a green P, and I put it at the 50-yard line, Soldier Field itself would be where the electron is located. So the P itself would be the nucleus, and everything else around it would be where the electrons are located. So on your note packet here, I have given you a periodic table as well, but it has some of the different groupings that we have. We're not really focusing too much on that in this course, but you do need to know a couple things. Remember that the last column here are called the noble gases. Those we will definitely talk about in this class. Also note that the next door neighbors are fluorine, chlorine, bromine, and iodine. Those are also a particular group. Those are called the halogens. But our main focus in this course is going to be carbon, okay, because it's going to be talking about organic chemistry, and all of organic chemistry is carbon-based molecules. But we will also be looking at nitrogen and oxygen. We will also have some discussion with hydrogen. So again, hydrogen's way over here. So that is going to be important. So realize that on the periodic table, this one is pretty small, so I don't know if you can see it, but every periodic table has what we call a key associated with it. And this key has where you're going to find different bits of information. So remember that the top is always what we call the atomic number. The bottom is called the atomic weight. We're going to talk about each one of those. So please note that you're going to need to know atomic number is going to be the number that is on top. So if I look at carbon, it has a 6 on top. That's called its atomic number. And its atomic number is the number of protons. And that's what makes it the unique element of carbon. If it has 6 protons, it has to be carbon. It has to be carbon. So next page, when we're talking about elements on the periodic table, we are focusing on what makes different things unique. So first off, we are going to assume that we are neutral. If we are neutral, we're going to have the same amount of protons as we do electrons. So remember, protons are negative, electrons are protons are positive, electrons are negative. So we need an equal number of those in order for it to be neutral. But we also have things called ions. Okay, ions have lost or gained electrons. So again, they're not changing the number of protons, but they are changing the number of electrons. We have cations versus anions. So cations are positive, anions are negative. So a way to remember this is cations. The T is essentially a plus sign. That's going to be how you remember what the difference between those two are. So if you have a cation, you have lost electrons. If you are an anion, you have gained electrons. Okay. If that is the case, cations have more protons and anions have more electrons. Another word that you might have heard from first year chemistry is the word isotopes, okay? Isotopes have different number of neutrons, okay? So that's gonna be the key word that you need to focus on there. So we have something called isotope notation, Okay, there's two different ways of writing it. One is to write a number above the symbol, right to the left of the symbol, and one is to write a number next to the symbol or the symbol name. So I'm going to focus first on the one on the left here. So 41 is on top of calcium here. I'll make this a little bigger. So 41 is what we call the mass number. So write down mass number. Okay, and mass number for a chemist is the number of protons and the number of neutrons in the nucleus. Okay, so that's going to give us some vital information. The bottom number that you sometimes see is also given. So I'm going to write the 20 in here. And if you look at calcium on the periodic table, calcium has the atomic number of 20. Okay, so that means it has the it has the number of protons. So this is called its atomic number. So if you see isotope notation, mass numbers on top, atomic numbers on the bottom. Okay, so if I were to say how many protons, neutrons, and electrons, protons being P, neutrons being N, and E being electrons, the number of protons is going to be, again, associated with what element it is. So calcium is always 20, so it has 20 protons. Because I have no notice of that it is anything but neutral, I'm going to have the same number of electrons. So that's going to be 20 electrons. So what we could do, because the mass number is protons plus neutrons, protons plus neutrons, I could take 41 minus 20. That's why I like this isotope notation this way. I could essentially get the number of neutrons, which is 21. Okay. Realize that this notation is the same thing. So I could write Ca with 41 or calcium dash 41. This is the mass number. This, by the way, okay, is not the same as atomic weight or atomic mass, okay? That's a completely different thing. So the mass number is the number of protons and neutrons. You don't know the number of neutrons from the periodic table. So the calcium having this mass number is the most important thing, okay? So do note and keep this in mind, atomic mass, which we're gonna talk about in a little bit here, is not the same as mass number. Those are two completely different things in chemistry. All right, so to get a little practice, okay, you will see on your notes, I have given you a couple examples here for you to try the number of protons, neutrons, and electrons. So pause this video, take a periodic table out, and see if you can figure out how many protons, neutrons, and electrons. Now, please note that this is a charge on the outside of these, okay? So you can see that bromine has a -1, sulfur is a -2, and Fe has a +2. If it helps you out, you could write the atomic number underneath. The bromine, if you look it up on the periodic table, is 35, sulfur is 16, and iron Fe is 26. So you could always write that in when you were doing these types of problems. So again, take a moment, see if you could take a guess, and then take a look at the video. So as you could see, protons are easy to figure out. That's never going to be the question. The top number being the mass number, if you subtract that from the number of protons, will give you the number of neutrons. And then you have to look at the protons versus the electrons. Those are the two columns you need to compare. Since this says a -1, that means it has an extra electron. It has one more electron than the number of protons. So if you think of protons being positive, electrons being negative, I have a +35 and a -36. So that will give me, if I add them together, a -1, which is the charge of this particular ion. So realize that the protons don't change. What is always going to change when you are forming an ion is going to be the number of electrons, okay? The number of protons always stays the same because that is, of course, what makes it bromine, what makes it sulfur, what makes it iron.